How to solve radical equations. That's going to be the topic for this lesson. Radical equations is just equations that have radicals in them. So square roots, cubic roots, fourth roots, fifth roots, etc. So how do we solve those? Well, in the previous lesson we learned a special method, the square root method, for solving certain types of quadratic equations. And that method basically consisted in taking square roots on both sides of an equation. So for example, this one is a quadratic equation that is ripe for the square root method. And what you do there is, if you remember, you take just square root on both sides to get x. To get x from here, you just take square root on both sides, but you have to remember that when you take square root on both sides of an equation, you have to put plus or minus on one side. So that was like the rule. But to get x from this side on the left hand side, to get x all by itself, we have to do square root on both sides. So that's going to give you just x. So in this example, you would have x equals plus or minus 6. And here's another example. Suppose that x minus 3 squared equals 5. To get the x all by itself, first take square root on both sides, remembering to put plus or minus on one side, so you would have x minus 3 equals plus or minus square root of 5, and then move the 3 over. So you would have x equals 3 plus or minus the square root of 5. So to put this in other words, or to say it otherwise, what is happening is to eliminate a square exponent or an exponent of 2, we took square roots because squaring and taking square roots are opposite operations, so they cancel each other off. So if you have x squared equals 9, the opposite of operation of a square is taking square roots. So you take square root on both sides, but remember that to put plus or minus one side, and you would have that. Actually, the opposite is also true. If you want to undo a square root, then you square, because it's still true that square roots and squares are opposite operations. So to undo one, you just do the other one. So if I have an equation that has a square root, then in order to undo that square root, or get rid of it, you would do the opposite of taking square roots, which is squaring. But when you square though, you don't put plus or minus. You just square both sides, and that would be it. So in this example right here, square root of x equals 3. To get rid of that square root, square both sides, and then the square root and the square cancel each other, and you will get just x, and on the other side you will get 9. So x equals 9. Okay, so now let's summarize the steps on how to solve equations containing radicals. So there are 4 steps, 3 for actually solving the thing, and there's a 4th step that is just verifying that, well, we found works, which is very important. But okay, so here are the first 3 steps for finding x, or finding the values of x. So step 1 is going to be, you're going to isolate the radical or rational exponents. If that's, this method actually also works for equations that have rational exponents. We're going to focus on the radical ones. Okay, so first thing is isolate the radical, meaning you want the radical all by itself on one side of the equation. All by itself on one side of the equation. So just like in here. I want the square root all by itself on one side of the equation. Once you have the radical all by itself on one side of the equation, you're going to raise both sides of the equation to a power that will eliminate the radical. So if it is a square root, the opposite of a square root is squaring. If it is a cubic root, the opposite of a cubic root is cubing, raising both sides to the 3rd power. If you have a 4th root, then you raise both sides to the 4th power, and so on and so forth. And again, that really works with rational exponents. So if you want to eliminate an exponent that is 2/3, for example, you raise it to the opposite the reciprocal of 2/3, which would be 3/2, and so on. So this really does work for other types of exponents as well, even though we're focusing on just radicals. All right. Once you have raised both sides of the equation to a power that will eliminate or do the opposite of the radical, you're going to solve the equation that resolves. So the radical is going to go, it's going to disappear, and you're going to have an easier equation that doesn't have any radicals. And you're going to solve that by whatever method is appropriate. So factoring, completing the square, quadratic formula, any method that is appropriate. And lastly, so that's going to give you the values of x. Lastly, though, for this type of equations, radical equations, it is not enough to know that you have not made any mistakes. Okay, even if you do everything perfectly, that's not enough. For radical equations, you have to check that the solutions actually work. And that's true for even powers. For if we have to raise both sides to an equation that is of even powers, like 2, 4, etc., you have to do this. This is not optional. So if the power is odd, then you don't really have to, as long as you know that you didn't make any mistake. But for radical equations in general, it's good to just do it, get used to it, even if the exponent is not even. So you have to check that the solution actually works by going back to the original equation, plugging it in, and making sure that everything actually works out perfectly. Because this procedure, what happens is that this procedure is actually going to give you the potential solutions or the possible solutions, but not necessarily the solutions. So it might give you, let's say, 3 numbers that could be potentially solutions, but only one of them works. Or maybe 2 of them work, maybe all of them work, or maybe none of them work. And there's no way of knowing that ahead of time besides just plug it in and working it out, each and every one of them. So that's the painful part. It's kind of annoying, but you really have to do it. Is an important part of solving an equation by radicals. I mean, a radical equation. All right. So here's the first example. So first step is you want the square root of the radical all by itself on one side of the equation. In this example, it's already done, right? There's the square root is all by itself on the left. So step 1 is done. Step 2 is you're gonna raise both sides to an exponent that is the opposite of that radical. So for square roots is squaring, for cubic roots is cubing, for fourth roots is raising both sides to the fourth, etc. So this one is just squaring, that's a square root. So we're going to, I'm just going to copy this again and then write squares on both sides. So square both sides. Okay, and then that is just going to get rid of the square root. So the square root and the square cancel each other, and that's just going to give you what is inside. And on the other side, you just square. So 4 squared is 16. And you see, now you have an equation that doesn't have any radicals, and that one, this one is easy to solve. So let's solve it. This is moving the 14. You would get 16 minus 14. So that gives us, divided by 11, negative, in the next step, negative 11, this is 2. So this is x equals negative 11. Sorry, I got the backwards. Negative 2 over 11. Negative 2 over 11 is our potential answer. I don't know if that's the answer right yet. We have to check whether it works or not. If it doesn't work, then we discard it and say there's no solution. But let's see. So let's do that part. Check. Alright, so take that number and plug it in and simplify it and see if it works out. So I'm going to plug it in the original equation, 14 minus 11, and I'm plugging in negative 2 over 11. Question is it true that that's equal 4? I don't know. Let's see. So take your time, simplify one step at a time. Don't rush it. Simplify, cancel in here the 11s, so the 11s will disappear, and then you would have two minuses that gives you plus. So that's going to be 14 plus 2, question mark, is this true, equal to 16? And simplifying a little bit more, 14 plus 2 is 16, so question is the square root of 16 equal to 4? And that is true. This is true. So that means that number right here that we found is actually a solution indeed. So that is the solution. All right, so that was the first example. Let's do another one. Let's solve this equation. 1 plus square root of x plus 5 equals x. Okay, first step, we want the square root all by itself. I don't want anything around it, so this one right here needs to go. Okay, I don't want that there, so we need to move that. So moving the 1, this is going to become square root of x plus 5 equals x minus 1. Okay, now the square root is all by itself on one side. That's good. That's step 1. Step 2 is now I'm going to raise both sides to an exponent that gets rid of the radical. This is a square root, so that means we're going to square both sides. Okay, so square both sides. The square root and the square cancel each other off, and what you're going to get on the left in this case is just x plus 5. On the right hand side, you have to square that. And for squaring, you either have to write it out twice and FOIL this and simplify, or you can use a shortcut, which is what I'm going to do because I like the shortcut. The shortcut is, remember, square the first one plus square the second one. So 1 squared or negative 1 squared is positive 1. And then there's a term in the middle, which is you multiply both of these. So negative 1 times x. Negative 1 times x is negative x. And then you double that. So negative x, double that is negative 2x. So minus 2x. Okay, and that's what you should have got if you do it the long way, which is writing it out twice and FOILing. Okay. Now that you have squared, you see now we have an equation that doesn't have any radicals, and we can just solve by any method we want. This is a quadratic equation in particular. So let's move everything to one side, so we have 0 on the other side. So this is going to be x squared. When you move the x over, it's going to become minus x, and then combined with this negative 2x, you're going to have negative 2x minus x, that's negative 3x. And then moving the 5 is minus 5, so 1 minus 5 is minus 4, negative 4. Okay, and now you solve that any way you want, quadratic formula, factoring. This one factors, x minus 4, so x plus 1. Okay, and then setting each factor equal to 0. The first one gives me x equals 4. The second one gives me x equals -1. So we found two potential solutions. We do not know whether these are solutions. Okay, we cannot forget about double checking. You have to check for your answers for rational equations and for radical equations. Knowing that you didn't make any mistakes is not enough. Remember that. Okay, now let's check. So let's check. First, I'm gonna check x equals 4. Okay, so let's plug it in. X equals 4 in the original equation. This one has to be in the original equation. So 1 plus square root of 4 plus 5. Is it true that these things are equal? Is it true that when I plug in x equals 4, you get an equation that is true? All right, I don't know. It's not obvious. We need to simplify this. So take your time, simplify, and see if it works. Is it true that 1 plus square root of 9 equals 4? Well, square root of 9 is 3, so is it true that 1 plus 3 equals 4? Yes, that's true. So that means x equals 4 is a solution. Okay, x equals 4 is a solution. So that one is. That one works. Now let's check the other one. The other one is -1. Okay, now let's plug in -1 in here. So I'm plugging in -1. Is it true that that's equal to -1? I don't know. Let's see. -1 plus 5 is actually 4. Is it true that this is equal to -1? Well, square root of 4 is 2. Is it true that 1 plus 3 equals 1 plus 2 equals -1? No, this is false. Right? That is not true at all. So what that means is that x equals -1 is not a solution and needs to be discarded. That's not a solution. It needs to be discarded. So our answer is x equals 4. Okay, and just because you check one that works, that doesn't mean that it is the solution. You have to check both or all of them if you have like 3 or more. You have to check all of them because it could happen. Let's say you found three potential solutions. It could happen that all 3 of them work. It could happen that only 2 of them work. It could happen that only 1 of them works. It could happen that none of them works. You really have no way of knowing until you actually plug them back in and check. Okay, here's another one. I recommend that you pause the video and try to solve this one. See if you follow the procedure and then compare notes with me. Okay, let's solve it. First step, I want the radical all by itself on one side. So that means I can move the 3x to the other side. So this is going to be 2 minus 3x equals square root of 5x plus 6. Okay, so now the square root is all by itself. So that completes step 1. Step 2, raise both sides to a power that will eliminate the radical. In this case, again, is squaring because I'm talking about square root. That was a cubic root, which we'll do an example in a minute. It will be raising both sides to the third. Okay, so here again is squaring. So 2 minus 3x squared equals square root of 5x, 5x plus 6 squared. Okay, and what that's going to do is it's going to get rid of the square root on the right hand side, so this is going to be just 2 minus 3x squared equals 5x plus 6. Okay, now square the left hand side, either write it out twice and FOIL or use a shortcut. Shortcut gives me square the first one, so 2 squared is 4, plus square the second one, so that squared, if you square this, you're going to get 9x squared, right? Negative 3x squared is positive 9x squared. And then there's a term in the middle, which is you multiply both of these, so negative 3x times 2 is negative 6x, and then you double that. So negative 6x doubled is negative 12x. Okay, so multiply both of them and then double that. So negative 6x doubled is negative 12x. All right, and then equals 5x plus 6. Now we got a quadratic, which we need to solve. Move everything to one side. So we're going to have, and put it in order. So 9x squared, and then negative 12x minus 5x would be negative 17x. And then positive 4 minus 6. Positive 4 minus 6. That would be minus 2. Okay. And then we need to solve that. You can solve this any way you want. Quadratic formula, factor in, anything. Doesn't matter. I think this factors. How does that factor? I think that factors like that. So I'm going to let you figure that out, or just use a quadratic formula. And now set each factor equal to 0. So this one is going to give us negative 1/9, and this one is going to give us x equals 2. Okay, so we found two potential solutions, but we have to check both of them. Okay, so let's start by checking the negative one. So check. Let's do this. Okay. So I'm going to start by checking the first one. So we're going to check x equals negative 9, 1/9. So is it true that 2 equals 3 times negative 1/9 plus the square root of 5, negative 1/9 plus 6? Is it true? Well, we don't know. We're going to simplify. Take your time, one step at a time, and see if this works. So canceling a 3 here, you get negative 1/3. This is negative 5. Multiplying here, negative 5/9 plus 6. And then, what is negative 5/9 plus 6? Let's do that in another piece of paper. You can use your calculator, but I'm going to do it by hand. So what is that? So common denominator is 9, so we have to convert this to 9s. So multiply top and bottom by 9. 9 times 6 is 54. And then this will give me 49/9. So this is 49/9, okay? 49/9. Which, square root of 49/9, well, square root of the top is 7, square root of the bottom is 3. So question mark, is it true that 2 equals, and now what is that? That would be 6/3. Is it true that 2 equals 6 over 3? And yes, this is definitely true. So that means that x equals 1 over 9 is a solution. It works out. It checks out. And now we're going to check the other one. Now we're going to check x equals, we're going to check x equals 2. Ooh, maybe not that. Let's check x equals 2. All right, x equals 2. All right, let's plug in. You're going to get, is it true that 2 equals 3 times 2 plus square root of 5 times 2 plus 6? Okay, I don't know. We need to simplify this to figure that out. 3 times 2 is 6. 5 times 2 is 10, and 10 plus 6 is 16. Okay, is it true that 2 equals 6? Square root of 16 is 4. Is it true that 2 equals 6 plus 4? Well, definitely no. That is false. So that means x equals 2 is not a solution and needs to be discarded. This is not a solution. So that means the only solution is negative 1/9. Okay, so going over the steps real quick, you need the square root all by itself. So move this to the other side. Once you have the square root all by itself, get rid of it by raising both sides to the second power. Once you raise both sides to the second power, don't make a mistake squaring that here. That's a common source of mistake. So remember, you write it out twice or FOIL or use the shortcut. Then you get a quadratic that you solve any way you want. You get two numbers that are potential solutions. You need to figure out whether they actually work or not. Plug them in. The one that works is the solution, and that's all. Okay. Now let's do an example that has a cubic radical. All right, solve this equation. Okay. First, we want the radical all by itself. So move this -1 to the other side. Move that. Because we want the cubic root all by itself. So that would be cubic root of 2x minus 1 equals 1 plus 1, which is 2. Step 1 is done. Step 2, raise both sides of the equation to a power that will eliminate the radical. So the opposite of cubic root is the cube. So we're going to cube both sides. So this is going to be 2 to the third equals 2 to the third. Okay, and then the cubic root and the cube cancel each other out, so that was the whole point. So you get 2x minus 1 equals 8. And then this would be 2x equals 9, moving the 1. And then that divided by 2, that's 9 over 2. And that is the answer that we got so far. Okay, and then actually, because this is an odd index, and we raise both sides of the equation to an odd power, you don't really have to check this one, as long as you're sure you didn't make any mistakes. But it's not a bad idea to get used to checking it regardless for radical equations. Okay, so we're gonna check this real quick. This is only gonna take like 2 minutes. So check So you get -1. Is it true that -1 plus cubic root of 2 times 9/2 minus 1 equals question mark 1? So we know is this is going to work, right? So this is -1 plus cubic root of, you cancel the 2's, you get 9 minus 1 question mark, is that equal to 1? Cubic root of 8, is that true? That's equal to 1. Cubic root of 8 is 2, and -1 plus 2 is 1 indeed. So yes, this is true. Okay, and we expected that because, as I said, for um, equations of odd index, as long as you didn't make a mistake, the answer, the number that you find is the actual solution, is going to work. So I didn't really need to do that for odd indices. For even indices like squares, you always have to check. Okay, try that one on your own before I do it. All right, so let's do it. So move the 3 over because I want this step 1, which is squared all by itself. So you're going to have 2 square root of 2x minus 7 equals 5 plus 3, which is 8. Okay. Then I'm going to divide by 2. I still want the square root all by itself. Although technically you could really just square right now if you wanted to. As long as you're careful that you would have to square the 2 and get rid of the radical, you could square both sides right now. But I'm just going to divide by 2 first. Okay, so you have that. And now you square both sides of this equation. And that's going to give us 2x minus 7 equals 16. 16 plus 7 is 23. So it means x equals 23 halves, potentially. I don't know. I don't know if that's true. I don't know if that works. But we're gonna figure it out pretty soon. Okay, by checking. So now let's plug it in and see if that works. So is it true that 2, so I'm gonna plug it in there, 2 times square root of 23 halves minus 7 minus 3 equals 5. 2 times 23 halves, well, the 2's are going to cancel, those 2's inside, and you're going to get just 23. So square root of 23 minus 7 minus 3 equals 5. Is that true? Well, I don't know because it's not obvious yet. So keep simplifying. 23 minus 7 is 16. Minus 3 is true that that's 5. Still not obvious. Square root of 16 is 4, so 2 times 4 minus 3. Is it true that that's 5? Now it's clear, because 2 times 4 is 8, and 8 minus 3 is 5. Yes, this is true. So that means x equals 23 halves is indeed a solution. Okay, we're going to do a couple more examples and that will be it. Which I suggest you should attempt both. You should try to solve both of them and see whether you succeeded. All right, first, let's do C. First step, um, have the square root all by itself on one side. That's already done in here, actually. That's done, so we don't have to do anything for step one. Step two, get rid of the radical by raising both sides to an exponent that gets rid of it. The opposite of squaring, of taking square roots is squaring. So raise both sides to the square. Square both sides. Then the radical and the square root cancel each other, so you're going to get 5x minus 6 equals x squared, and we're going to solve this quadratic. So move everything to one side. X squared minus 5x plus 6. So now either use quadratic formula or factor. I think this factors quite easily as x minus 2x minus 3. And then you're going to get x equals 2 or x equals 3. So we have two potential solutions. We have to check both because we don't know whether any of them works, both work, or none of them. Okay, so we're going to plug in first x equals 2. Let's see, let's plug in x equals 2. Check. Let's first check x equals 2. So if I plug in 2 there, is it true that square root of 5 times 2 minus 6 equals 2? Well, square root of 5 times 2 is 10. 10 minus 6, is it true that the square root of 10 minus 6 is 2? Yes, because 10 minus 6 is 4 and the square root of 4 is 2. This is true. So that means x equals 2 works. That's a solution. How about x equals 3? Let's see. Square root of 5 times 3 minus 6, is it true that that's equal to 3? I'm plugging in, remember, x equals 3 on both sides. Is it true that, no, 3 times 5 times 3 is 15. 15, is it true that the square root of 15 minus 6 equals 3? 15 minus 6 is 9. Is it true that the square root of 9 equals 3? Yes, this is also true. So that means both of these numbers are solutions. So this equation has two solutions, x equals 2 and x equals 3. All right, and now let's do our last example. Okay, first step, move everything to, isolate the radical. So move the x, the square root of negative 5x plus 6 equals x. Square both sides. So this is going to be square both sides. That's what you get, which simplifies to negative 5x plus 6 equals x squared. Now solve this quadratic, whichever way you want. Moving everything to one side, have 0 on the other, you're going to get x squared plus 5x minus 6, which factors as x plus 6, x minus 1. So that gives you x equals negative 6 or x equals 1. So we have two potential solutions. Now let's see if either of them works. So let's check. Let's start by checking x equals -6. So is it true in the original equation? Is it true that -5 times -6 plus 6 minus, be careful with the signs, minus x, but x is equals -6. So minus -6 equals 0. I don't know, question mark. Is it true? Okay, let's simplify. -5 times -6 is positive 30. Positive 30 plus 6 minus, and minus, that's positive 6 equals 0. Is that true? Positive 30 plus 6, that would be square root of 36. Is it true that square root of 36 plus 6 equals 0? Well, the square root of 36 is 6, and 6 plus 6 is definitely not 0. So this is false. So that means x equals -6 does not work. That is not a solution. That is not a solution. Okay, now let's check the other one. X equals 1. Now let's plug in x equals 1 in the original equation. So, is it true that -5 times 1 plus 6 minus 1 equals 0? Well, let's see. Square root of -5 times 1 is just -5. -5 plus 6. -5 plus 6 minus 1 equals 0. -5 plus 6 is 1. So is it true that the square root of 1 minus 1 equals 0? Well, the square root of 1 is 1, and 1 minus 1 equals 0, so that is true. So that means that x equals 1 actually does work. So x equals 1 is a solution.